I've always wanted to convert this mill over to a flood cooling system. I've been thinking about it for years, and there's reasons I don't do it just because it's complicated. The ideal way is you build an entire enclosure around the machine and just let it go to town, getting coolant everywhere. If you're not exactly familiar with flood coolant, if you just look up industrial CNC machine on YouTube, I almost guarantee it's going to be running flood coolant. Doors close on those big machines and coolant blasts on the cut, and the work goes forward. That's done that's done for a multiple of reasons. Basically, what it's doing is it's pushing all the chips away from the cut. It's cooling the tool, it's cooling the work, it's adding lubricity to the cut. Basically, it lets the machines work harder with better surface finishes and better tool life. There's a reason it's done in industry, because it's efficient. Most hobby machines like this aren't set up for that. They're set up for either like an air blast or manually application of cooling or oil or whatnot. This thing, I'm using it more and more for production every day, and I'm using it on materials that benefit more and more from flood cooling, titanium especially. So I thought the easiest way to go about this was, instead of building an entire enclosure, I could test my system by essentially building an aquarium, if you want to think, around this table that would contain most of the mess, and basically let me experiment with the system. And then when I have time down the road or whatever, if I purchase equipment that works better for flood cooling, I would be better off for it. So I decided to go down this road of basically a simple flood cooling system, and that's my misadventure that I share with you today. So the first step in this whole process was to kind of have a rough idea what I wanted to do. Basically what I was going to start with is a stainless steel plate on the back of the machine, stainless steel plate on the front to kind of get around the vise and everything, some acrylic side pieces that I just had floating around. These are all pieces that I had, so I didn't have to purchase a lot of this stuff. And with that, I could relatively seal the system. I used my CNC router to cut a lot of the acrylic to size. I drilled and tapped it to basically fit it all together. The stainless, I drilled, and then I had I had a dovetail on the front of this mill that I could mount angles to relatively seal the front plate up. The back, I didn't have any attachment points. It's a nice smooth back. I didn't want to drill into the mill because I wasn't fully convinced that this idea was going to work. So I wanted it to be completely backwards compatible. This machine makes me money, and I can't totally have it go down. So it's kind of important for me to be able to undo what I do to it. But anyways, the double-sided tape to hold the aluminum plate on the back, or the stainless plate on the back, worked out quite well. I had everything fairly buttoned up. Any areas that had large gaps, I used either like a double-sided foam tape or a closed-cell foam to basically seal off any major leak points. I didn't want to rely on actual sealants, like caulking and whatnot. That's kind of like a secondary measure. There's a reason your shingles on your house are put in the fashion they're put on. It's because it naturally sheds water with physics and gravity. You could technically shingle your house the other way and like seal every single shingle, but it's going to last like a month before you have a bunch of leaks. So you also want gravity on your side. The way I was building this, gravity was not on my side for a lot of it. I was depending on seals and depending on that. And that was flawed from the jump, but I thought for this application, it didn't have to last for years. It just had to last for months. It should work out. So I moved ahead with that. The pumping system I used a 2-gallon container, and basically for coolant is oddly expensive, especially good coolant. You mix it with water. The stuff I was using is a soluble oil, and that's basically just added to the water mixture to keep your tools and fixtures from rusting away. So I purchased some fairly low priced, it's still like up in the hundreds of dollars a range, but some fairly inexpensive coolant from my local supplier. You have to buy it in large volumes, unfortunately, as well. Mix that in my sump, my old 2-gallon bucket. I used my old float tank mag drive pump, which has ample flow. It can flow 1 to 2 liters per second, which is more than I'll need for my small application here. Plumbed it up into a system with a bypass, and the bypass would allow me to do secondary filtration to get fine particles out of the mix. It would come up the mill where my existing airline was, and I changed the bores and diameters of this block so it would work with 3/8 hose, so I could just get a little more flow through it. I didn't know how many nozzles I was going to have, so I wanted to try to make this as simple as possible. So change that size out, put a larger nozzle on my old air blast system. For the drain, I basically found a nice silicone overflow hose for, I think, a washer, and decided to use that as my main drain for this table setup here. I had a secondary drain in the back that would drain just the T-slot, and worked out quite well in my head at this point. I 3D printed a little bracket to kind of keep everything nice and tight and close to the mill and to avoid hitting the dovetail or dovetail ways and everything. And on my first test, it worked okay. I had filled the mill with coolant, basically just without running a cut, just pumping it through and seeing how everything flowed and where it moved. And I had a ton of stagnant coolant issues, which I thought at the time, it's an issue, but it might not be an end-all issue. So I decided to move forward with it. I had a couple minor leaking areas, which I fixed with sealants. Once again, bad idea, very temporary, but once again, this was just going to be a stopgap. So I sealed them all and went ahead and moved forward with a cut, or almost moved forward with a cut. I actually, while I had that sealing issue with coolant leaking out of the enclosure, I also had it leaking onto the spill tray, which that's designed for. It's fine, it can take that, so it has a lip on it. But it also is bolted into my stand, so that means coolant could migrate down the threads and leak into my stand, which is not what I wanted. So I actually lifted the mill and lifted this pan up and put some rubber gasketing between that, then thread sealed the bolts and then put them all back in. So now I know if any coolant, oil, whatever gets on this pan, that's as far as it's going to go. It's not going to go any further. That's annoying because it's like 300 pound, 400 pound mill now with all the fixtures and everything on it. So lifting it isn't trivial. Anyways, got all that set up. Got the coolant mixed, set my mixed ratio right so I have enough coolant per water mixture to avoid rusting issues, set up the cut, everything was good to go, and I ran a few pocket clips. Titanium is kind of one of my more difficult cuts, and it worked well, but it caused me more issues than it solved. So when I run this mill normally, I just use an air blast system. I basically point the nozzle at the cut, turn the air on, hit cycle start, walk away, go do something on my lathe, go work on my computer, do something else while the mill is doing its job. It's my employee. It works, so I don't have to do that. That's how I leverage my time with efficiencies. In this method with this flood coolant system I designed, I had to babysit it the entire time and constantly be moving the nozzle and adjusting it, and then I would move it too much and it would start hitting the tool, and the tool would start flinging the coolant, and then it would get everywhere, and it was causing me more trouble than it was actually helping me. Yes, I could probably push the cutting harder because I had much better chip evacuation. I don't even know if I had better chip evacuation, but I had better cooling. So I could probably push the cut harder, but I still have to be there, and that's not a benefit to me. So I decided I had to rework the system. And the more I thought about it, the more I realized this was on shaky legs right from the jump. It was never built to be a long-term solution, but it was already too poorly designed to work out, which is unfortunate because I hate sinking time and money into a project that isn't a success. And this isn't a success, this is a failure, but I don't regret it for 1 second because the amount it taught me was phenomenal. Like, I would never have learned what I learned in the last week by not doing this. Like, no amount of reading would have taught me that. So I'm happy I did it. I hate losing time too, because that's finite. Anyways, so after my scratching my head and trying to sleep on it for a few days and think of better ways that I could source it, the best way to do it is to build a full enclosure around it, the thing I was trying to avoid at the start. So I decided at this point, in order to basically optimize my production right now, the best thing for me to do was to remove it from my mill, bring it right back to stock, and just carry on with my current method that I'm using until down the line I go down a different path of either a machine that's fully suited for flood cooling or to build a proper full enclosure for this when the time suits me. So we spent the next few hours stripping the mill down. The problem with pumping a bunch of coolant onto the mill, a water-oil mixture, is it gets everywhere. Thankfully, it didn't get into the motion system because that's kind of how I designed it not to. But it got into every single fixture and my vices and my fourth axis and under the fixture plates and just everywhere. So I stripped the entire machine down, basically took all the oil and grease off it, re-oiled it, re-greased it, you can see the fourth axis vice fixture or a board jaw chuck still isn't on there because I took it apart, sitting behind you, and re-greased it as well. Just to prevent any rusting issues. When I first built this mill, when I put fixture plates down, I oiled the bottom of the fixture plates and then put them down. And over the last 4 years, 3-4 years that they've been mounted on there, I've never had rusting issues. So I wanted to make sure I didn't have any rusting issues. And those few days that I had the flood coolant running with just the stagnant water sitting on the mill, I already had minor surface rusting issues. So I knew that was going to be a problem. So cleaned everything, oiled everything, greased everything, put it all back together, realigned everything, realigned my fixture plate, realigned my vise, realigned my 4th axis, touched off all my, actually I haven't touched off all my mill turning tools yet, but a lot of work that I wish I could have avoided, but unfortunately that's the nature of the beast. To properly clean it, I had to do that. So we got it back to a position now, which honestly it's way better than when I started. It is so much more clean. Everything is perfectly adjusted. Our airline is now a 3/8 line, which means I get a lot more flow out of it. I have a convenient valve here now, which lets me adjust the air blast much easier as well. I changed just a bunch of things to make life easier. Little annoying, even the lights. The lights were annoying because the way they were mounted to the mill was just, they were not mounted nicely, and I was always fiddling with them. So now it's better. So it's not a total waste because I've actually made my life a lot easier. I just spent about a week doing a full circle. So I want to share with you guys. Sometimes you just learn, well, Kurt told you earlier in the video, learning from failures is sometimes a lot nicer than learning from successes because they stick harder and you go through a lot more things a lot quicker when something doesn't work out. So I'm happy I went through with it. Not so happy I wasted all the time, but was it a waste? Probably not. So that's where I've been for the last week. So that brings us to now. Basically, the nice thing about working on shop production, shop efficiencies and whatnot, and losing out on production is it really renews the vigor to try to crank some production out. So this weekend, I blanked up about, 20 or so bolt body pens, EDC bolts. Those are going to be the next drop. I have some of the difficult machining completed on that already. I threw some titanium ones in there as well. I'm not fully satisfied with the efficiencies that I'm going through for the machining of the titanium. I'm happy with how they're turning out. They're taking me a lot longer than I planned for them to work. But the only way to get better at doing it is by doing it. So I threw a few into this batch. We'll see how those go. The one thing I'm very, very excited to machine is this. So this is the most expensive material I have ever purchased with the intention of machining. This is Meteorite. This is a frickin' rock from space. The patterns in it, I'll list the name of it here. I can barely pronounce it. Just a bunch of letters and vowels. But it's the way that metal, this is primary iron and nickel, and the way it cools over millions of years in space, you get this really cool lattice striation pattern. And as far as I know, the only way to create that pattern is in space over that long time cycle of cooling. So we're going to work that into a pen. That's why my website has always been so space centered. I've had this idea in my head for years to machine and integrate into my products. So I'm very excited to start working on this. That's probably what next week's video is going to be about. Just because it's such an interesting material. Yeah, who doesn't want to touch a rock from space? Having something in your hand that you can touch that's literally from, like, potentially from another galaxy, just amazing. I don't know, it blows my mind. Last week, Mars, the rover thing, if you haven't watched that, go check that out. Some incredibly intelligent people doing some amazing things. But yeah, I don't know. Space has always been super interesting to me. I'm happy to work that into a product. I'm going to ramble about space if I keep sitting here. So I will see you guys next week. Take care. Bye.